So in part two of solving trig equations, we're going to look at how some of our identity information can help us solve these trig equations. So if you take a look at this example, it says find all solutions of the sine squared minus sine plus 1 equals the cosine squared. And you'll notice that on this example, they only care about answers from 0 to 2 pi. You see how there is a bracket on the 0 but a parenthesis on the 2 pi. That tells you that you don't have to include 2 pi. You just have to include 0 if it's an answer. Okay, so we're going to just look at the answers from 0 to 2 pi. So like one cycle around your unit circle. Now, in this particular case, we have multiple trig functions showing up. We've got sines and cosines. But we know a fact about cosine squared. If you recall, we know that sine squared plus cosine squared is equal to 1. And if we rearrange that, we know that the cosine squared is 1 minus sine squared. So to make the solving process easier on us, let's take out cosine squared and let's replace it with its equivalent, 1 minus sine squared. Now the reason we do that is so that the only trig functions in our problem are sines. Now you'll notice our highest power are sine squared. So let's get all this to the other side of the equation. So we would get 2 sine squared minus sine. The 1 would be subtracted from both sides, so it would be 0, which we don't need to put, and then a equals 0. Now this is a perfect spot to use our u substitution, so I'm going to let u equal the sine of x. And let's substitute that in wherever we see a sine of x. If the sine of x has a squared, then our u has to have a squared, and so on. So it would be 2u squared minus u equals 0. Now, if you recall how to factor something like this, because both terms have a u in it, you can just take a u out. Since they are factored quantities, we can set them both equal to 0 and solve each one independently. This first one, u equals 0, is solved, but 2u minus 1 equals 0 is not. Solve it for u. Now let's put our trig function back on. Our trig function is sine of x. Put that back on. So we get that the sine of x equals 0, or the sine of x equals 1/2. Now remember what that's asking. That's saying on the unit circle, where would you get a sine value of 0? On the unit circle, where would you get the sine value of 1/2? Well, remember, our sine value is equal to 0 when the height at that particular point is equal to 0. So let's think of that as far as radians go. That would be 0 and also pi, 0 and 180. So that would be the two answers for that particular piece. For our second piece, the sine is positive in the first two quadrants, quadrants 1 and 2. The sine is equal to 1/2 at the 30s. If you take a look at the point at 30, the point at 30 is square root of 3 over 2 1/2. Remember, the y value of your point indicates what the sine is doing. So that's why we want the 30-degree reference angle in the first and second quadrant. In the first quadrant, that's 30 or pi over 6. In the second quadrant, that is 150 or 5 pi over 6. So we end up with 4 answers: 0, pi, pi over 6, and 5 pi over 6. Any questions about that? Just a sec. Let's look at another example. Now, for this problem, you'll see that our sine in here and a cosine in here. And even if we move the 1 and got it equal to 0, there's really no way for us to factor it. Even if we make one a u and one a z, there's no way for us to factor it. The only relationship we have between a sine and a cosine is the fact that if they are squared, we know stuff about them. We don't know things about them individually. So let's take and let's square things to help us. So let's surround the entire side by a square. Let's actually physically square it. Now remember, if we square the left side, that's sine of x minus cosine of x times sine of x minus cosine of x. We have to actually physically FOIL that. So we get sine squared minus 2 sine of x cosine of x plus cosine squared equals 1. Now what happens here is a trick that we saw happen in our identities, that sine squared plus cosine squared we know is equal to 1, so it can be replaced with a 1. Now what's nice about that is there's a 1 on each side, so if we subtract a 1 on each side, we get negative 2 sine of x cosine of x equals 0. Now if two things equal 0, we can split them when they multiply. We can split them up and each individual thing can get its own equation. So we have negative 2 sine of x equals 0 and cosine of x equals 0. It doesn't matter which one you stick the negative 2 on because we can just divide it out and then it goes away anyway. Okay. So we didn't even have to really use any kind of u sub for this one. It kind of just naturally works for us after you square both sides. Now you have to ask yourself, on the unit circle between 0 and 2 pi, where's the sine equal to 0? Well, the sine equals 0 at 0 and 180, or 0 and pi. Cosine equals 0 at 90 degrees, which is pi over 2, or 270, which is 3 pi over 2. So we end up with 4 values again for our answer. Now you can, like any other equation, plug these back into the original and they should work. Let's just take 1 second and plug in 0 into our original. That would say that the sine of 0 minus the cosine of 0 is equal to 1. And that would be a true statement. Well, actually, let's check it. Because of the fact we squared something, I think what's going to happen is a few of these might not work because of the fact that we squared some things. So we do have to check these because we forced a square into the problem. So let's check 0. So I'm just going to plug 0 back into the original. So I get sine of 0 minus cosine of 0 should equal 1. Well, the sine of 0 is 0. The cosine of 0 is 1. I don't get 1, I get negative 1, so I got to cross that one out. That one didn't work. Now let's plug in pi. I get sine of pi minus cosine of pi, and it should equal 1. Well, the sine of pi is 0. The cosine of pi is negative 1. Hey, that one works. So that one works. Now let's plug in pi over 2. I get sine of pi over 2. Sine of pi over 2 is 1 minus 0, which equals 1. So that one works. Now let's do 3 pi over 2. At 3 pi over 2, the sine of 3 pi over 2 is negative 1. The cosine of 3 pi over 2 is 0. That one doesn't work. So be careful for the ones like example 6. When you physically put a square onto a problem to try to solve it, you could get some erroneous solutions that when you plug back in, you get a negative when you should have got a positive. So those are the only ones that you really want to check your work when you're done, because you have to physically square things. So here is the assignment that matches the problems we saw today, 21 through 30. For those problems, you're either going to substitute in one of the identities that you know, or you have to square both sides in order for things to happen. So let me kind of give you a hint. Like if you look at 21, that is a perfect one to use your identities on. But 22, you want to square both sides. So that'll kind of give you an indication as to how it's going to proceed. If there's already squares in the problem, you're usually going to use one of your Pythagoreans. If there aren't squares in the problems, you're going to probably square both sides. So there you go. That is lesson 5.3, part 2.